there. Welcome to our first video for Math 0300. We are going to start at the beginning. If you are a Sound of Music fan, you know that there's a song that says begin at the beginning, a very good place to start. When you read, you begin with ABC. Well, when we count, we start with real numbers, but we start with some very special real numbers. We start with 1, 2, 3. These are the first 3 real numbers that you learn when you are little bitty. These are the numbers you learn to count with. These are the numbers that come naturally to us. We can see 1 object and 2 objects and 3 objects. They're right there in front of our faces. So because of that, these are more officially known as the natural numbers. And sometimes we get really lazy as math people, and we abbreviate the natural numbers as an N that kind of has 2 legs at the beginning to make it look a little fancy. Those are the first part of the real numbers that you learn. When you get a little bit older, you learn about a new number. You learn about 0. So you take all of those counting numbers you already knew, and we stick 0 in there. These are what we call the whole numbers. Zero, 1, 2, 3, 4. We still don't have any fractions. We don't have any decimals, only whole numbers, but we're including 0 now. Then you hit about 6th grade maybe, and you learn that there are other numbers, unless you've lived up north. Then you already knew about these guys with their super, super cold temperatures in the winter. After you learn about the whole numbers, you learn that if it's super cold outside, you might have temperatures that are -3 degrees, or -2, or -1, or it could be 0 degrees, or 1 degree. So now we're adding in the negative numbers. When we add in the negative numbers, we have wandered into the territory of the integers. We do have a symbol that frequently gets used for these. It's like a Z with a double bar. That one's kind of ugly. It looks like that. So these are the counting numbers, and they're negatives. But we still haven't covered the numbers you know about, because you don't just know about 0 and 1. You know that between 0 and 1, there's numbers like a half. Or you know you don't just have half a dollar, or you have $1. Maybe you have 3 quarters in your pocket. Maybe you have 75 cents. Maybe you borrowed $4 from your friend. So you owe him, or you have -$4 in your pocket. When we include the integers and fractions, we have added some more numbers. So this includes what we call the rational numbers. This includes fractions and decimals. Remember, though, that even whole numbers can be expressed as a fraction. I could go right down here and change this -4. I'm going to move it over. Remember, it can be written as -4/1. So now it's a fraction. All of these numbers are the rational numbers. Everything inside this it might be a square, might be a rectangle, this quadrilateral right here. Those are all the real numbers, or the rational numbers. But we've left out a couple. Some of you might be thinking, but wait a minute. I learned about pi in high school. Pi doesn't fit any of those descriptions because remember, pi is 3.1415962, and it keeps on going. It doesn't repeat. If you have used any square roots, you know that if you put the square root of 2 in a calculator, it's not going to give you a nice pretty decimal. There are other numbers that might fit in here. You could have the number e. I promise it's a number. It's 2.71 and lots of other decimal places. Numbers like these are called irrational numbers. And together, this set of irrational numbers plus the set of rational numbers creates this real number system. And the real numbers are all of the numbers you know. At least at this point in the game. So let's look at a definition of some of these. Some of them we'll talk about symbols, we'll give examples, and this will come in handy when you are trying to classify some number sets later. Let's look at the real numbers first. When we talk about the real numbers, we use an R with a double leg in the back. We already said this. I'm going to say it one more time because some of you, it'll be the first time. The real numbers are all the numbers you know. The negatives, the positives, the fractions, the irrational numbers, 0, the decimals, all of those are real numbers. Then we go to the natural numbers. These are the counting numbers. These are the numbers you learned on your fingers about. You learned 1, 2, 3, and you kept on going. And then you got older and you learned about 100. And then you learned about 1,000,000. And you could keep going, but we really don't have time for that. When we talk about symbols, we use an N with 2 legs on the back. For the whole numbers, we don't typically use a symbol for those. The whole numbers are all the natural numbers. And 0. So we did 0, 1, 2, and we keep on going. The integers did have a symbol. It was a Z with a double bar in the middle. If you don't cross your Z's, it's totally fine. If your Z looks like that, absolutely fine. Crossing my Z's was a habit I got into in my upper level math classes because my 2s and my 7s really started to look alike, and that became problematic. My 7s and my 2s and my Z's started to look the same, so I fixed it. Integers were all the negatives. All the negative whole numbers. All the positive whole numbers. And 0. Now, when I say all of the negative whole numbers, this part right in here, technically that's not the way we should say that, but for our purposes, I think it gets the point across a little bit better than some technical math speak might do it. So we're going to go with that. These would be -3, -2, -1, 0, and it keeps on going forever and ever. The rational numbers are where people forget that you can make a fraction out of any number, unless it's irrational. This is all of the numbers, positive or negative. Ooh, that doesn't say that. That can be written as a fraction. So one whole number divided by another whole number. Remember, though, that this includes the negatives, so we could have -2/3. This could be a +4. This could be 0, because remember, you can write 0 as 0/1. You could also have their decimal equivalents. So -2/3 could be -0.667. And the thing about decimals, and I'm going to put this as a little side note over here. The decimals that repeat or terminate. So 0.333333 repeating, or 0.37, it stops, count as rational. So maybe we put in that decimal. And that works because that's the decimal equivalent for 1/3. For the rational numbers, I think we usually use Q, but it doesn't happen that often. Irrationals. To me, these are the fun ones. These are the ones that do kind of interesting things. For our purposes, these are decimals. I guess I could put it in the box because these do not stop. So they do not terminate. Or do not repeat. So our examples for those were like pi, or e, or square root of 11, which is interesting. It is to me, not necessarily to you. The other way to find these is if you are taking the square root of an odd integer. And I don't know what I'm thinking because it's not an odd integer. It should be the square root of a prime. Now, if it's been a hot minute since you talked about prime numbers, we'll slide this down in here. A prime number is a number whose only factors are 1 and itself. So 11 is prime. If we looked at the square root of 3, 3 is prime, so that would be irrational. Square root of 2, all of those are irrational numbers. So let's go see if we can classify some of these. If we look through these and we want the rational numbers are the fractions. Well, here's a fraction. Here is a mixed number. That's a fraction. The decimals, that's stop. Well, 10.2 stops. 0.5 stops. The decimals that repeat, well, remember the bar over two numbers means that those two numbers are going to repeat. So this would be 1.232323323 until you run out of breath. Now this also includes the whole numbers because we could put our whole numbers over 1 and create fractions out of them. So we have to include the -8 and the 0 and the 35. That covers all of our rational numbers. Now the irrational numbers were the ones that don't terminate, don't repeat, or are the square root of a prime number. Well, the only option we have is this square root of 7. It was the only one that wasn't rational, so it had to be irrational. 7 is a prime number, so when we take the square root of it, we're going to get an irrational number. The integers were all of the negatives, all of the positives, and 0. Well, here is a negative and a 0 and a whole number that's positive. But for the integers, we had to throw out the decimals. So that means 10.2, negative 0.5, 7/5, all of those don't count as integers. What's next? The naturals. The naturals were the numbers you learned to count with. So you didn't learn to count with 10.2 or a negative 8. You didn't learn to count with a half or 0. You didn't learn to count with any of these except 35. The whole numbers were the numbers you counted with, so 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up to a billion, plus 0. So I'm going to pick out the 0 and my counting number. The real numbers were all of the numbers we've talked about that we separated into rational and irrational. So all of these, the rationals and the irrationals, count as real numbers. Now, when we talk about real numbers, we have to talk about bigger or smaller. And sometimes that can be hard because the negative numbers seem to be backwards. Even though the number gets bigger, so maybe if we want to compare negative 5 and negative 7, when the number itself gets bigger, the temperature or the number itself gets smaller. So sometimes it's easier to think about numbers when we're putting them in order on a thermometer. So if I go over to my thermometer over here, maybe I make this spot right here 0 degrees. And if I start at 0 and I get up and it is maybe -3 degrees, if I want my temperature to go colder, it would be -7 degrees, -11 degrees. So that actual number, the 3, the 7, the 11, those are getting bigger, but the temperature is getting colder. Then, as my temperatures increase in the positives, they of course get warmer. You're used to that part. So maybe this is 3 and 7 and 11. Sometimes that can help. So we're going to go put these in order. We are going to put it on a number line. I'm going to put the 0 right in the middle. Now, I'm not going to put every single line on my number line. You guys are old enough that we don't necessarily need that. What you might need is a little bit of conversions. Let's start with what we know. I know if I do 1, 2, 3, 4, 5, I've got that one on my number line. And then the next number on my number line would be this 5.26. I don't have to be exact. I know that $5.26 is more than $5 though. So I might stick it right in here. Now, if I look at the rest of my positives, I can guess about where 2.37 would go. Here's 1, 2. So 2.37 would be about in here. So I took care of this one. If I look at the rest of my positives, 0.15, that's like 15 cents. That is way smaller than $1. So I'm going to put it right down here. Now I have two more. I have a pi and I have a 2/5. The pi I know is about 3.14. So I can go put that on my line. I have a 1, 2, 3.14 might land right in here. 2/5, if you go put this in your calculator, you're going to end up with about 0.4. Well, that's smaller than $1, but more than 15 cents. Now I'm going to go put my negatives in there. So I'm going to do like I did on the positive side. I'm going to do -1, -2, -3, -4, -5, -6. I'm going to go out to -7 because I do have some -6 point some things. I know that if I start with -0.23, if I'm talking in terms of temperature, that's pretty close to 0. If I want it to get colder, but just by a little bit, I'd go to -2.1. That's going to be super close to -2. Then if it gets even colder, the next one on my number line would be -3. We've got that one already there. Now I have to decide which one is going to come first, the -6.51 or the 6.25. 6.51 is really close to -6.5. So if this is -5, I'd go to -6 and then halfway to -7. 6.25 would happen between -6 and -6.51. So there's the number line. It's not pretty, but it is entirely functional. If you have questions, feel free to shoot me an email or drop by my office. I will see you again on the next part of our journey for Math O300.